Hello, so this is a video about 2009 AB FRQ question 1 with calculator. This problem gives us a velocity graph with minutes on the x-axis and miles in the y-axis. Notice how each interval here is 0.1 mile, and these are in minutes. This is a relatively easy question, straightforward, but there may be a couple tricks that I will later specify when we get to the parts. We've seen these types of problems before, a simple velocity, acceleration, position function, and which are connected by derivatives and integrals. So start with part A. Part A is asking for the acceleration of Karen at 7.5 minutes. So this is just the slope at 7.5, because we know that acceleration equals v prime of x. So we can solve this by just taking the slope between 7 and 8. That equals 0.1 miles per minute squared. One thing tricky about this is that we have to remember that the interval here is not 1 mile but 0.1 mile, and to also not forget the units, miles per minute squared, because it's asking for acceleration. So the point system for this part is just 1 for the answer and 1 point for the units. Alright, so now on to part B. So part B is asking for the meaning of the absolute value, the integral of the absolute value of v of t from 0 to 12. We know that the absolute value of a velocity function is the total distance, so in this case that'd be the total distance traveled, total miles traveled by Karen between 0 and 12 minutes. And we were also asked to find the value of this, and what we can do here is we can split this into two integrals. We can take the integral from 0 to 4 of the absolute value, and also the integral from 5 to 12, so the absolute value of this. From 0 to 4, we can think of this as two identical triangles with base of 2, height 0.2, and divided by 2, but since there's 2 of them, multiplied by 2, you get 0.4 miles. Remember that this y-axis, the interval is 0.1, not 1. And as we continue for the integral from 5 to 12, you can count the number of boxes here. That's 3, 5, 7, 9, 11 and a half here, which in this case would be not 11 and a half miles, but 1.5 miles. And then we add these two triangles here, here, and here. That'd be 0.3 times 1 over 2 plus 0.2 times 1 over 2. That'd be 1.4 miles. You add these two together for the total distance, and you get 1.8 total miles. And in this case, the grading would be 1 point for this definition and 1 point for this value. Alright, so this is part 3. I'd say this is the easiest part of all the questions. It's asking for the time Karen returns home to get homework and the reason. So looking at this graph, we can see that at 2 minutes Karen's velocity goes from positive to negative, so that means she turns around, and so the answer would be at 2 minutes, Karen turns around, returns home. Because v of t goes from positive to negative here. This is a very straightforward question. It should be fairly easy. The grading for this section is fairly easy. It's 1 point for the answer, 2 minutes, and another point for the reason. Alright, now for our last section, question D. It's asking us to compare Karen's distance from the school to Larry's distance from the school. So put Larry up here, and Karen here. We can do Karen first. As we calculated, the integral from 5 to 12 of v of t dt equals 1.4 miles. Notice that we're not taking the total distance, the absolute value, or incorporating these. Even if we did these, we cancel out, but since Karen turns home, she actually restarts to the school at 5 minutes, so therefore we only need to take the integral from 5 to 12, which happens to be 1.4 miles. For Larry, it takes him 12 minutes to get back to school, using the function w of t, so we can just take the integral from 0 to 12 wt dt through our calculator, because this is the calculator section, and that answer would be 1.6 miles. So because Karen lives closer, Karen lives closer because she lives 1.4 miles away, while Larry lives 1.6 miles away. I'm kind of running out of room. So Karen lives closer. So the scoring for this question would be 1 point for Larry's integral here, 1 point for Larry's value, 1.6 miles, and for Karen, there's 1 point for the value, and also incorporated to that point is our explanation and conclusion that she lives closer. If you still don't exactly understand this FRQ, there's also a couple more FRQs that are quite similar with connecting velocity, position, acceleration. So one of such examples is 2015 question 3. Although this is no calculator, it gives a table of values and makes you estimate, for instance, acceleration or also total distance. Another question similar would be 2004's question 3. It's another question that has to do with velocity, although it's also no calculator. It connects velocity and acceleration. Lastly, there's also the 1998, a little older, AB scoring guidelines. For this question, it has to do with acceleration mostly. And so these questions are good examples of College Board questions that also have to do with velocity and acceleration. Hope that's helpful.